right, good morning, everybody. So the next question that I had a request for was question 50, so we will dive right in. The question reads, the solubility of two slightly soluble salts of M2 plus Ma and Mz2 are the same, 4 times 10 to the negative fourth moles per liter. Part A wants to know which is the larger numerical value for the solubility product constant. Remember that solubility product constant is just KSP. And so in order to think about this equation, this question, I wrote out the equilibrium equations for both Ma and Mz2. So Ma dissociates into M2 plus and A2 minus. And remember that Ma is a solid. It's also a salt, and then it dissociates into two aqueous ions, and so we don't include Ma in our KSP expression. So the KSP is just the product of Ma2 plus times A2 minus, and then I can very easily just sub in X for each of these concentrations because they're going to be equivalent since we don't have any coefficients out front, and that's how I get KSP is X squared. Come over here to Mz2, dissociating into M2 plus 2Z minus. In this case, the KSP is M2 plus times Z minus squared, because remember, we need to take this coefficient and make it an exponent. I'm going to say that M2 plus is X, and then Z, sorry, this was a Z, I have to say is 2X because of this 2 coefficient over here. So when I plug and chug into the KSP expression, I'm X times 2X squared, and so we are going to distribute the 2, and this becomes 4X squared times X, 4X cubed. 4X cubed is larger than X squared, and so the KSP value of Mz2 is larger. Part B asks, in a saturated solution of each salt and water, which has the higher concentration of M2 plus? The answer is just that the concentration is the same for both of the saturated solutions. And this is due to the fact that the molar solubilities are the same for M2 plus in both expressions. There is 1 mole of M2 plus per mole of salt, and that's seen in both expressions, right? 2 plus, M2 plus. And this should have been M2 plus, not Ma2 plus. I'm seeing my error there now. So this would just be M2 plus. Sorry about that. And then part C, if you added an equal volume of a solution saturated in Ma to one solution saturated Mz2, what would be in the equilibrium concentration of the cation M2 plus? So we're told that X is equal to 4 times 10 to the negative fourth molar. And so this guy over here is the KSP expression for Ma. I plug in 4 times 10 to the negative fourth molar times 4 times 10 to the negative fourth molar, since I'm just using X up here. And I get 1.6 times 10 to the negative seventh. Down for Mz2, my KSP is equal to 4 times X cubed. So you get 2.6 times 10 to the negative 10th. M2 plus is 4 times 10 to the negative fourth molar. After the addition, the moles of M2 plus increase, but so does the volume. And so in this case, M2 plus actually is just going to remain the same. And that is question 50. Let me know if you have other questions beyond what I just explained here.